Okay, one other way that we can use the Bcd function, okay, is if we understand this here, okay, and this rule here is basically that the sum of all probabilities is equal to 1, okay, such that the probability of x being greater than or equal to 4 is equal to 1, take away the probability of x being less than or equal to 3. Okay, now in this circumstance, okay, the majority of those selected favoured the red party. It asks us for the probability where x is greater than or equal to 4. Okay, so just understanding this, then we can use the Bcd function without having to change the probability to the circumstance of a failure. Okay, so I'll show you what I mean. Alright, so we're calculating this probability of x being greater than or equal to 4, and we know that it's equal to 1, take the probability of x being less than or equal to 3. Now BCD is a calculation of the probability being less than something. Less than some number k, less than or equal to. Okay? So what we're saying is, we're going to use this number 1, and we're going to take away the probability of x being less than or equal to 3. Okay, so still, the number of trials is 7. The number of successes is 3. So we're saying here, we could have 0 successes, 1 success, 2 successes, or 3 successes. Okay? And the probability of a success, again, is 0.35. Okay? If we calculate that, we get we get 1, this is equal to 1 take away 0.80015, okay, which you could write as basically 0.199 or 0.2. Alright, which is what we calculated before for this one. Okay, so that's just another way of using the Bcd function. Alright, it's just having an awareness of, if it's asking us the probability of x being greater than or equal to 4, we can change it and still use the same probability, as long as we understand we can write it like this: 1 take the probability of x being less than or equal to 3.